Okay, folks, we're into the 100s now, the 101st installment, still in Chapter 8, Section 8.3, Unit 9 in the course, Scale Diagrams in Context. Okay, so let's see if we can do some practice problems. All the same stuff we did before, but now we're just doing practice problems with them. So the first thing we want to do here is we want to see what the question says. The floor plan for a shed is drawn to scale on 2-centimeter grid paper. Okay, using 50 to 1, or 1 to 50, I should say, scale factor. What is the perimeter of the shed, including the door? So perimeter is the distance around. So let's get the distance around the image and then figure out what the distance around the actual shed would be. So we've got a scale factor of 1 to 50. So each block, if this is 2-centimeter grid paper, represents 2 centimeters. So for instance, this block up here, or this side of the shed up here, that's 2 blocks long, would be 4 centimeters long. Okay? This one right here would be 2 centimeters. And then this one, which is 3 long, is going to give us 6. We have another 3 right here, and that will give us another 6. And here we have 5, so that's 10 centimeters there. And then over here we have 4, which makes 8 centimeters. So if we add all those together, we get the perimeter of this one. And perimeter is still a linear measure. It's not like an area or a volume or something. So we can just take our scale factor of 1/50th and divide by that, or multiply by its reciprocal, which is 50, on this diagram. Add up all those dimensions to make perimeter 8 plus 4 plus 2 plus 6 plus 6 plus 10. And we'll take 50 times all of that stuff. So what we have here is 50 times, let's see, 12 and 2 is 14, 6 is 20, plus another 16 is 36. So 50 times 36 will give us the perimeter of this guy, which is 1800. So we have a perimeter of 1800. Now this is in centimeters. If we want to know the perimeter of the actual shed, we've got to convert centimeters into meters, because all the answers that we have to work with are here in meters. So I divide 1800 centimeters, or multiply, let's use unit analysis, we've been using that all along, by 1 meter per 100 centimeters. So the centimeters cancel out. 1800 divided by 100 is 18 meters for the perimeter of the shed. Okay, there we go. Good stuff. Next question. A wheelchair ramp has a profile image in the shape of a right triangle. The ramp is 6 meters long and reaches a height of 1.5 meters. Draw a scale diagram to the ramp, and using a scale factor of 1 to 100, and assume the grid squares are 1 centimeter by 1 centimeter. Okay, so if we're going to go 1 to 100, then every meter will shrink down to become a centimeter, because that's 1/100th of a meter. So our ramp was 6 meters by 1.5 meters. So when we scale that by 1 over 100, that's like 1 over 100 times that would be 6 over 100 meters, which we could call 6 centimeters, times 1.5 centimeters. Okay, so we divide everything by 100 and we get that. So if I'm going to draw this, all I have to do is draw a diagram that's going to be 6 centimeters long. And if this is 1 centimeter grid paper, 2, 3, 4, 5, 6 to there, and then 1.5 centimeters tall, right to there. And then we play our favorite game, connect the dots, draw those out, use a ruler if you're not me, and then what we get is our wheelchair ramp. That's 1.5 by 6, only these are in centimeters instead of meters. The scale diagram. Okay, hopefully that's helpful. Those are a couple of questions about how we use linear distances and scale things on scale diagrams, contextual problems. And it's useful to first determine the scale factor, of course, and then use your formula if you need to do that. So once the scale factor is determined, required dimensions can be calculated quite easily. And from there, the problem can be solved using rates sometimes. Often can be solved using rates. Okay, we saw some of those earlier. Good luck. Hope that helps.